first four terms in ascending powers of x of the binomial expansion of 1 plus kx to the power n are 1 plus ax plus bx squared plus bx cubed, where k is a positive constant and a, b and n are positive integers. Part A. By considering the coefficients of x squared and x cubed, show that 3 equals n minus 2 times k. So let's expand this 1 plus kx to the power n out. So my first term would be nc0 1 to the power n kx to the power 0. My second term would be nc1 1 to the power n minus 1 kx to the power 1. My third term would be nc2 1 to the power n minus 2 kx squared. The third term would be nc3 1 to the power n minus 3 kx cubed. Let's simplify each of those terms now then. So nc0 is 1, 1 to the power n is 1, and kx to the power 0 is 1. nc1 is n, 1 to the power n minus 1 is 1, and then kx to the power 1 is kx. Next, nc2. Now you might not be remember that off the top of your head, but that's fine because we can use the Ncr formula to work this out. So the Ncr formula is n factorial over n minus r factorial times r factorial. So if we are doing nc2, then we'll have n factorial over n minus 2 factorial times 2 factorial, which is the same as, well, n factorial is like saying n times n minus 1 times n minus 2 times n minus 3, and so on. The n minus 2 factorial is the same as saying n minus 2 times n minus 3 times n minus 4, and so on. And then we have the 2 factorial, which is just 2 times 1. Now what we see is the n minus 2's will cancel out, the n minus 3's will cancel out, and everything after that would cancel out. Just to leave n times n minus 1 over 2. So that is my nc2. Then my 1 to the power n minus 2 is just 1, and my kx squared is k squared x squared. We now have nc3. So again, let's use the Ncr formula to work that out. So nc3 is equal to n factorial over n minus 3 factorial times 3 factorial. N factorial, again, is just n times n minus 1 times n minus 2 times n minus 3, and so on. The n minus 3 factorial is n minus 3 times n minus 4, and so on. The 3 factorial is 3 times 2 times 1, which is 6. We're now going to have some simplification. The n minus 3 will cancel with the n minus 3. There'd be an n minus 4 that will cancel with the n minus 4, and so on. So that's going to simplify to be n times n minus 1 times n minus 2 over 6. That's my NC3. And then the 1 to the power n minus 3 is just 1, and then the kx all cubed is k cubed x cubed. Let's now simplify each of those terms. The 1 times 1 times 1 is 1. The n times 1 times kx is nkx. Then we have n times n minus 1 over 2 times k squared x squared. And then we have the n times n minus 1 times n minus 2 over 6 k cubed x cubed. Right, so that's me expanding this 1 plus kx to the power n up to the x cubed term. Now, notice that the coefficient of x squared is b, and the coefficient of x cubed is b. So that's saying that the coefficients of x squared and x cubed should be the same. So I'm going to take my expansion now and make the coefficient of x squared and the coefficient of x cubed be the same. So let's make those equal to one another. Now I've got a bit of space here. So, like I say, the coefficient of x squared is this. The coefficient of x cubed is this. So let's equate those two. So we can say n times n minus 1 over 2 k squared is equal to n times n minus 1 times n minus 2 over 6 times k cubed. Right, now to simplify this and hopefully show that it's going to reduce to the 3 equals n minus 2 times k. So I can times both sides by 6 to get rid of this denominator. So if I times both sides by 6, then on the left hand side here I've now got 3n n minus 1 times k squared, because the 6 divided by the 2 is 3. And on the right hand side the fraction has gone now. Next, I can divide both sides by n. I'm allowed to do that because I know for a fact that n can't equal 0. If n equals 0 here, it would be a bit of a silly expansion to do. 1 plus kx to the power 0 would just be 1. So we know that n is not going to equal 0, therefore I am allowed to divide both sides by n. Similarly, I can divide both sides by n minus 1, because I know that that also can't equal 0. I can also divide both sides by k squared, because again I know that that can't equal 0. So that leaves me with 3 is equal to n minus 2 times k, which was what we needed to show. So that's part A done. We're now told that A is 4. So that's the coefficient of x. So we're now told that my coefficient of x, which is nk in my expansion, is equal to 4. So I'm now told that nk equals 4. And part B says find the value of n and the value of k. So we are now going to be solving simultaneous equations with these two equations to work out what n and k are. So let me rearrange here to make k the subject. So I'm going to say that k is equal to 4 over n, and substitute that into this second equation. I'm going to times both sides by n, and I'm going to expand those brackets. So therefore n is going to equal 8, which if I substitute that back into the left-hand equation there, I find that k is 1/2. There we go.